So we're talking about the ILVK Upper Colorado River Irrigation and Restoration Project, a project on the main stem of the Colorado River. The main thing you're probably wondering is, what does the ILVK stand for? These are my neighbors, some pretty interesting characters. I've got to work with them pretty closely over time. The truth is I don't like reading from slides, and this is up on your screen. If you'd like more information about Senate Document 80 and others, we can send this out. But basically, when the Colorado Big Thompson project was constructed, they knew that the peak of the hydrograph was going to be cut off. So many of the ag producers in the lands of the vicinity of Kremling, so ILVK is irrigators of the lands in the vicinity of Kremling, they knew that the fields would no longer naturally flood within the riparian corridor. And so they granted water rights that were associated to them. So we're very tied to the Colorado Big Thompson project and what it means for all of us. So it includes mostly irrigated land on the main stem of the Colorado. It does include some water rights on the lower Blue River as it confluences with the Colorado, and then also includes some water rights on the lower Muddy as it confluences with the Colorado. But it bound us, Senate Document 80 bounded us together forever. So here's a little map that demonstrates the different pump facilities. So these aren't all of the different irrigation water rights that are associated with ILVK. There includes some on the blue, and then, like I also said, on the Muddy, and additional irrigated lands out of the KB ditch. If you can, not sure, probably see my mouse on the screen. True ILVK includes all of this irrigated land, basically the entire Colorado riparian, and then also all of this going down towards Gore Canyon, and this on the lower blue. But to just give you an idea, we are right around the Kremling area. So if you've ever driven in this valley, you've probably seen those odd wood structures that are placed haphazardly. The land is so flat down there that when they built most of the project, most of the water rights were actually tied to fixed station irrigation pumps. So the Bureau of Reclamation came in, dropped a fixed pump in, built a bunch of different irrigation delivery systems, largely elevated ditch systems, but the soil base down here is so sandy, as it's kind of the taper of the valley floor as the Colorado flows into Gore Canyon. That is kind of an interesting design to consider, because elevated ditches with that were built primarily out of sand have equaled some challenges over time. That project and what our river looks like, I think that many projects, alter flows in the Colorado River and this stretch of river beyond just the Colorado Big Thompson project, certainly many Trans-Mountain diversion projects, and then as well as a number of different reservoir systems. But I think that pretty much until the early 2000s, the landowners really never felt some of the full force effect of what could happen based on altered river flows. 80s and 90s, relatively positive hydrology, and the river system functioned and worked. But you can tell that bank there in this photo looks oddly tall relative to the water table, and that's exactly what all of us producers experienced in the drought of the early 2000s. And so we were looking at flows that were significantly less than they had historically been at high flow for irrigation systems, and many different impacts to the river system. So these are inlets to one of the fixed station pumps in the project area at that low flow. In order for these to operate at 80% efficiency or better, they require being submerged by at least 18 inches of water or more. And you can see here, this is a springtime irrigation with the top of the pump inlets sucking air. So the system was not working at that low flow Colorado River. This would be an example of, I would call it a temporary check diversion that was put in the river to backwater up and elevate to the pump system. In the background, you can see one of those wood structures where the pump inlet sits up in this area here. And this was done out of great care and attempt for the producer, but not a lot of thought processes of what it would happen, to the river with its installation. And it being temporary, and you can see here on River Right, clearly it had failed pretty rapidly. This is the mighty Colorado River, the Grand River, at a low flow there in the stretch of the early 2000s. Pretty sad to see what's happening, very low water table, hard for irrigators to access their water, and then you can imagine what we're talking about with water temps at a river that's flowing that low. So what we did, we were able, Northern and Denver had their collective firming projects on Windy Gap and Moffett collection system going on in the mid 2000s, kind of right as the tail end of the hardcore drought up here was hitting home. So Grant County was pretty aggressive in early stages of stream management planning. And I don't think the topic of this should really focus too much on Grant County stream management plan, but based out of necessity, Grant County pretty much came in and said, we're moving forward with this plan. We want to engage as many stakeholders as possible, but we don't have enough science and data to really accurately reflect potential changes to this river system and what it means scientifically. We can talk about what additional depleted flows mean, emotionally or, as a matter of visual impact. But more science and data was needed. So Grant County got very aggressive with it. If others would like additional information, it's available on Grant County's website, and I'd be happy to forward that link to Phil and Aaron to send out. But what was a great thing for the producers down here of the ILVK is that study gave us enough information about the river system to start thinking about this river more as a connected system than just individual private property areas, and then also diversion systems, whether they be ditch or pump, that we knew that, this river functions as a system, and in order to have any kind of proper fix or repair to it, that I think that our approach to evaluate it as a system would be better. So as everyone knows, this takes a long time to build trust and relationships to work on these kind of things. So while this was going on in the early and mid 2000s, it took a long time for these landowners and producers to be connected. I should have said there are 13 individual landowners of what are considered ILVK water rights. So the 13 different producers within the system make its whole. Many of them have multiple diversions, but it's 13 different landowners. So what we were able to do is basically take a look at Grant County's stream management plan, piggyback on the information that was learned, what science and research had already been studied and was ongoing being monitored, and then be able to evaluate our system a little bit more efficiently and effectively to understand what it would take for repair. So within the project reach, I would say a little more than 50% of the producers were primarily concerned about their ability to operate their ag diversions and their agriculture way of making a life. Many were balanced in both, as a great care for that, but also recognized the need of the health of the river. The river wasn't just failing for, our diversion structures. It was kind of coming unraveled as we speak. And so Phil mentioned my background, but I was fortunate to have a fly rod in my hand at a young age, but out of financial necessity, I started guiding right after school in 2003 to supplement my income. That's where my parents have always been really proud of me because I chose to be a cowboy and a fishing guide to earn a living. My wife isn't overly impressed sometimes. It's a great way to make a living though. But so with that, in 2012, the landowners had finally bonded together enough to approach the Colorado Basin Roundtable, and we asked for $50,000 to give our kickoff assessment. So knowing what work had been completed for Grant County Stream Management Plan, the Roundtable voted yes to the grant. The landowners put in $54,000, and we had a $104,000 river assessment for a lot of miles of river. And it was intended really to understand more of the global picture and the systematic approach to the river. It wasn't intended to, have 100% design of restoration efforts for what was necessary, but at least, for us to get our hands around it in a format of an assessment. But it was really the first time historically that the producers of the ILVK had come together and never had any kind of a victory, which I find to be amazing. My family had to relocate up here from the Front Range right in the year 2000, but many of these producers are on the same ranch, multi-generational up to 4 and 5 generations. And while different projects had aligned their interests in past history and they had worked together on certain things, in many's eyes, there had never really been a moment of victory for these producers. They'd kind of been working independently within the river system. And so with that grant, one of the first things that we identified working with Grant County Stream Management Plan is this is a hydrograph of the Colorado River at the confluence of Troublesome. So that's about 3.5 to 4 miles upstream of the town of Kremling, main stem Colorado River. You can see here that historic peak flow, well over 6,000 CFS, and post firming projects for Denver and Northern. This is what our river was kind of slated to look like going forward. And all of our irrigation infrastructure, I would say, was built for somewhere in between. Not necessarily what was the historical peak, but I don't think that anyone thought this would be down below 1,000 CFS. So this is a beautiful photograph that I pirated from an unnamed individual that I have never given proper credit to, and I apologize for that. He's probably seen it in one of my presentations. But this is looking upstream, just past Kremling. Coming in from the north side here is the confluence of the Muddy. Coming in from south here is the confluence of the Blue River, and then this is the main stem Colorado River going up valley, from which it's in Kremling. So just a nice kind of landscape view to take a look at some of the land that we're talking about participating in this project. So we're back to this good old photo. We had started the river assessment. I would say at the point in time this happened, we were about halfway through, and we had one of the producers approach us and say, basically, if we did not find a way to have his pumps function properly by the following construction season, that he was going to find a way to do it himself, which historically landowners had used everything from chain tires to you name it to back up water, divert for the pumps. So that put the engineers and I at a great moment of struggle. We left that producer's property that day, came back to our shop, which if none of you have ever been here, things like this are known to happen from time to time, but we sat down with a 30-pack of PBR and agreed that no one was leaving the shop until we had a plan for that producer, which made for an interesting evening. But we were basically, this is the exact location of where this diversion structure was. This particular diversion structure functions for 3 different water rates. It's a 3-pump system out of the same hole. And that night, I think this is the sketch we actually made that night in the shop. But part of the research from the river assessment had indicated that within a 1/4 mile of this particular area, there was a stonefly count done in 1980 prior to the construction of the Windy Gap project. And there was a riffle that was studied about a 1/4 mile from here that was a productive riffle that had an abundant stonefly population. Present date, it's hard to even picture what a normal functioning riffle looks like in this stretch of river, because it's mostly sandy bottom, very little size river substrate, cobble, basically a sand pit with very tall banks surrounding it. And part of what the river assessment concluded was that the river has been incising basically for the last 100+ years. So part of the research indicated that there was a very large meandering oxbow of the Colorado River that was cut off by one of the producers to allow that producer to gain access to their land. So it ended up shortening the length of the Colorado River by about 1.33 miles. That propagated a head cut. So the river was kind of eating itself alive, trying to find its happy balance of length and slope during that time. And so it kind of, the water table over time just kind of kept eating itself down. So the theory with the engineers became, well, if we know we want to elevate the water table again, that's going to do 2 positive things. It's going to submerge the irrigator's pumps. It's going to create some additional habitat. And then also as a byproduct of this, you know, the water table shouldn't be that disconnected from the surface where we all try and produce our hay crops from. And by elevating the water table, there's a kind of a less of a sponge in between the surface where we're flood irrigating primarily, and then where the water table is located. So that turned into reality, and this is riffle number 1 post-construction. We learned a couple of lessons in the construction of it, but in a river system of this size, it was there were some model other riffles that had been done over time. This one looks a little bit different, but it was kind of our first go. Riffle number 2 came a year after this one. And what has happened now is a series of 5 different water diversion structures or riffles that help to re-elevate the water table to what it historically was prior to the removal of that oxbow that shortened the length of river by so far. And what you can see in this photo that's so incredible is that you can instantly see these banks look like the photos where I showed you before prior to construction, where it wasn't this vegetative connectivity between the land and the water prior to the construction of this, which this diversion structure actually elevated the surface water of the Colorado River here by about 22 inches. And And so the water table went immediately back up to the vegetation. And the aftermath of this, with 5 of them working together within about a 5-mile stretch of the river to work on elevations, is we've seen a remarkable connectivity from the vegetation back to the river, where we had planned a number of locations of additional bank stabilization and stream restoration that really, by elevating the water table, became unnecessary based on how it was connected. So I would say we learned a lot from doing number 1, and it was a little bit properly permitted and went through the process, but it was a little bit cowboy in the beginning because this landowner wanted to be so aggressive in working on the river system, but it kind of proved to spearhead and launch the whole project in a greater capacity because of what was done here. And so this riffle now, we study, monitor it. This will be its 5th season in the ground. Basically every rock has a GPS coordinate and a name. We study what it does on the tail out of it as far as water depths. So within a riffle, it's the same as any grade control structure for a diversion. Within this photo, I should have been a little bit left of where I am, but the 3 pump systems sit just upstream, right here on river left. But we designed this riffle after what was agreed with Colorado Parks and Wildlife, local aquatic biologists, to be some of the healthiest existing natural riffles in the Colorado River, as far as its width at low flow, its width at high flow, its slope, and therefore its velocities, and then also what that ends up creating for scour depth at the tail, so that the project was designed primarily to function as a diversion structure for the irrigator, but also to see how we could create a man-made structure that might act as a naturally functioning riffle to bring back some of the aquatic habitat that used to be there, both as far as what happens with the river, but then also macroinvertebrates and a glorified way of saying it, fish food. So we have been incredibly impressed with the project. My screen is stalling, I apologize. Uh-oh. There we go. Apologize, but so this is the this is part of that 3 intake system in the before photo, before the grade control structure. Same flow of the river. This is what the pump system looks like in the after. So you can tell how dramatically we increase the elevation of the river there for those particular pump systems. And with that, I imagine I'm speaking primarily to ag folks, so you guys know as well as I do, but you know, this is important for all of our heritage and what we do to make a living. We need abundant supply of this. This is the great aftermath of this. This photo is taken specifically on that riffle within the first year of its existence, and it was actually less than that, about 9 months. It had one of the most abundant golden stonefly hatches of anywhere on the Colorado River system, and we've kind of tend to refer to this project a little bit as the field of dreams, that when we've created the platform for quality things to happen, if you build it, they will come, and they have showed up quick. This riffle system now, not an intent of the project to begin with, but my family, the fishing business that we operate, we actually lease this producer's land now to run as part of our commercial fishing operation. So those sand pit photos of what you saw in the before, we actually operate it now as part of our paid commercial fishing, and the production is there as far as trout fishery to work. That's one of the byproducts of the riffle. And then you know what we all do, back to the same cause. And so this is where what's been so neat during the process of this project is, while I said in the beginning, you know, over 50% of the producers were much more focused on their infrastructure, and whether it was specifically to a diversion structure and assured supply of water delivery to their diversion systems, or many of the ditches that were constructed as part of the CBT by the Bureau of Reclamation were in jeopardy, had failed, in jeopardy of failing within washing into the river because of so many of our steep eroding banks. And so the bank stabilization portion, you know, was very significant to secure landowners proper irrigation land. So, but in the end, ultimately, this is what it's about. And then what the great part of this, one of the producers in the beginning had told me that if I ever mentioned the words trout unlimited back to back on the ranch, they'd run me off their place. That producer now is on the brink by maybe 3 o'clock this afternoon of signing their 4th contract with Trout Unlimited, acting as a fiscal agent to the grant that they received to work on some of these issues. I think there's been kind of a change because the goal really with working with grant opportunity was that for many of these producers that couldn't afford to build, healthier river systems or a healthier river system, and really just to protect their agriculture, we tried to bring in the grant dollars to support that, where what maybe was a little bit of a lower dollar model of a restoration effort to support their agriculture. We kind of upgraded the level of that restoration effort to both service to upgrade their agriculture infrastructure necessary for their productivity, but then also to address the health of the river within that hydrograph at the beginning of this presentation. It's a big gap in water to flow down every year, flushing flows, what it means for velocities and everything else. And so essentially part of the river project by bank stabilization and other efforts is to kind of build the river within a river. We know that this stretch will still have flood flows and positive snowpack years, especially multiple of them back to back. But we also know we can see years, summer of 2018, the last week of May and the first week of June, that hydrograph that indicated above a 6,000 CFS annual average flow. The Colorado River hovered between 135 CFS and 142 for 2 weeks, when in a typical year we were seeing our peak flow. So we're trying to create a river that functions, with a very adjusted flow to it. I had to throw this one in. This is my daughter in the hayfield, and I happen to love her quite a bit. But we're pretty excited. But that was kind of the kickoff start to it. We still have all these problems. So if you tour about 12 miles of river down here, this is essentially what it looks like, unfortunately. Eroding banks. This particular photo is taken in a location where one of the irrigation laterals literally sitting in the river. Here's an example of that bank and some of the engineering drawings that we have to restore that, including tow wood matrix, and then also using root wads to buffer. Another example of what the stretch of river looks like in the before. Here's some examples of the details of the wood matrix. For those of you interested, again, I'm happy to share all these things. This particular grant was an award that we received after the initial roundtable grant. This was from the Colorado Water Conservation Board at a total of $465,000, matched exactly at a 1-to-1 by the landowners. So landowners definitely have plenty of skin in the game. They're working on this as aggressive as their finances allow them to. But that upgrade is kind of what we see as being able to create that healthier river system beyond just buffer and protect the agriculture. So these are all CWCB cost shared drawings. I'm happy to share them with anybody. There's nothing too special about them, but this one right here in particular is what was neat, where we got to at a time and place. Many of the landowners, they say, why would we put wood in the river when we have access to rock? Rock is a lot harder and more durable. Not necessarily recognizing some of the habitat benefits to the system and also producing the same end result for what we were looking to do. And then this would be the engineering drawing details of some of the root wads. We had access to some flat rock, so this was slightly modified during construction, only that we were using a little bit more slabby flat rock rather than more round glacial moved boulders. And this is the end result in the aftermath. We cannot believe the positive impacts it's had to the health of the river system. There formerly was a ditch when you're looking at this photo that had washed into the river that the landowner could no longer push some irrigation water to one of their meadows. That ditch has now been moved off the river by about 50 feet, plus or minus, with the bank restored like this to put less of the seep water in the ditch impacting the saturation of the bank that was potentially aiding and likely aiding in some of the riverbank erosion. But in a nutshell, the irrigators back to irrigating their land in full capacity. And the river in this stretch, we narrowed the channel width appropriately based on 3D modeling for present hydrology. And just so all of you know, we work with very smart engineers. That's not me. I'm just saying what they say. But we work very closely with the engineers on this for what it means. So this isn't haphazard, you know, how far out into the river any of these root wads and rocks are placed. Basically at a minimum flow, low flow river, where we're looking to see a certain river width, and then still allow for a greater river width at a high flow so that we're not choking the floodplain as high flow events would come. So this has been a great example of an incredible win-win. This stretch